and welcome to our FF Plus interview session. In this interview, we speak with Kevin Charpot, CFD engineer at Oceanwings. Welcome, Kevin.
Thank you. Hello.
So let's dive right in. Can you briefly introduce Oceanwings and explain what sets your wind-assisted propulsion system apart in the maritime decarbonization landscape? So how does your team contribute to innovation in the shipping industry?
Yes, so Oceanwings is a French SME that designs and delivers Oceanwings, an articulated wing system for wind-assisted propulsion. It's a two-element rigid wing, a main element and a flap, that adjust automatically to get the best aerodynamic performance. What makes us different is the focus on automation and durability. Our wings are designed for real-world use on commercial ships. We combine aerodynamics, naval architecture, engineering to make wind propulsion reliable and scalable.
So what are the most complex engineering problems you face when designing and testing your solutions, and how you address them using HPC or AI?
Yeah, so for us, the biggest challenge is wind complexity at sea. Actually, every ship interacts differently with the wind based on shape and speed, and the wind conditions change all the time. So we have a huge number of design variables to study. We use HPC-based CFD simulation to explore all these combinations. It gives us detailed aerodynamic data, and it's the only way to evaluate that many cases with good accuracy in a short time.
How do Oceanwings engineers integrate HPC or AI into engineering and R&D workflows? Could you share some key use cases where these technologies play a crucial role?
Actually, HPC is part of our daily process now. We built an automated open-form pipeline that runs on HPC clusters. Once we define the inputs, it handles meshing, solving, and post-processing all in parallel. One major use case for us is stream optimization. For one ship, we run thousands of simulations to find the best wing and flap settings. HPC lets us do that in a few days instead of weeks.
So let's now talk a bit about your experience in the participation in the FF4EuroHPC Business Experiment. Could you share some insights into that experience? So how valuable was the opportunity for your company in terms of innovation, development, and collaboration with other organizations?
It was a real game changer for us. Before the experiment, we were using manual setups, and it didn't scale. With the FF4EuroHPC, we developed a robust and automated HPC tool chain tailored to our needs. And it also brought great partners. We worked with Politecnico di Milano, Cineca, Toolspol, and USI, and each brought important expertise. It really helped us to grow technically and made us part of the European Innovation Network.
So let's wrap up the interview with some final thoughts. So what advice would you give to other SMEs that haven't yet explored the use of HPC or AI in their business?
First, don't be intimidated. HPC is more accessible than you might think. But automation is key. The manual workflow don't scale. And also look for partners. HPC centers and university can help you get started and avoid common mistakes. And be clear on your goal. Use HPC to solve a specific bottleneck, like simulation time or testing too many configurations. And finally, train your team. Even basic skills in scripting or parallel computing can make a big difference.
So thank you for your very precious insight. And to continue, in your experiment, your team was supported by project partners you already mentioned. and we're developing a cutting-edge wing propulsion system for maritime transport known as Oceanwings. What business benefits did you gain from this development, and how has the experiments continued to support your company after the experiment concluded?
Thanks to the experiment, we now have a faster and more flexible design process. We can tailor Oceanwings to each vessel with more confidence and speed, and it helps us respond quickly to customer needs. And it didn't stop with the project. The simulation workflow we built is still in use, and we've even improved it. It's now part of our standard R&D toolkit. So it's every day.
So thank you very much, Kevin, for this excellent advice. It was a pleasure to having you with us today. And saying that, wishing you all the best in your future engineering endeavors. Thank you and goodbye.
Thank you. Thank you very much.